Bom dia a todos e a todas que estão aqui nessa manhã de quinta-feira, dia 20/5. Estamos estreando o nosso programa, o Fraunhofer Quick Lives. Eu sou o Dr. Rodrigo Pachli, sou head do Fraunhofer Liaison Office. Gostaria de agradecer você que está aqui ao vivo para ver essa live extremamente interessante. A ideia do Fraunhofer Quick Lives é a gente apresentar alguns temas, discutir sobre eles de forma rápida, para que você tenha noção do que está sendo feito no mundo e que nós possamos fazer juntos em parceria aqui no Brasil. Eu agora vou passar para o inglês para a gente conversar um pouco com o Dr. Simon Schmidt, né, do Fraunhofer IBP, que vai falar um pouco aí sobre novos materiais na construção. Hello, Dr. Schmidt. It's nice to have you here. Thank you very much for accepting our invitation. It's a great pleasure to know a little bit more about the new materials for construction. I'd like you first to present yourself and then you can go with your presentation.
Yeah, thank you, and welcome. Thank you for having me here. It's a really pleasure to be here and to present the results that we have researched. So my name, as mentioned before, is Simon Schmidt. I'm from Fraunhofer IBP, which is the Institute for Building Physics. I will have one slide about that. I'm a civil engineer and in the research for now more than 8 years, working a lot with different aspects of the building physics, but especially also with new materials. And in this case, and also for this presentation, especially in the realm of renewable-based materials, which I will present in a minute.
Please feel free to put your questions in the comments, whatever you want to put there. If you have any doubts, any questions, you can put there, and we're gonna, during the live, we can talk a little bit about it, and after the presentation from Dr. Simon Schmidt, we can discuss a little bit these questions, okay? So, Dr. Schmidt, sorry, the stage is yours.
Yeah, wonderful, and thank you. And you can see the presentation now. And first of all, I would like to introduce on 2 to 3 slides what Fraunhofer is. So Fraunhofer itself is an institution, research institution, one of the biggest applied research institutions in the world. We have a finance volume for around about 2.8 billion euros, a staff of around about 28,000 people, and at the moment 74 institutes, which can be more over the time. And I'm, as I said before, out of one of these institutions, which is named the Fraunhofer Institute for Building Physics. Some facts about it: we have 246 employees at the moment, 40% of which are women. Our operating budget is around about 30 million euros, and out of the 7 managers that we had so far, 2 are in place right now, which is Professor Klaus Sedelbauer and Professor Philipp Neisner, which are leading the institute at the moment. The institute itself, as the name indicates, is working with building physics, and we are structured in 6 different departments, as you can see here. So we cover from the acoustics over the energy efficiency, indoor climate, life cycle engineer, hygrothermics, inorganic materials, recycling and environment, hygiene and sensor technology, the broad of the building physics in all the aspects. As you could assume, I am out of the inorganic materials and recycling. I am not. So I'm the head of the hygrothermics department, which works in the field of heat and moisture transport. And as you can see it here, our goal or our vision is to ensure durability, improve the hygiene, and create comfort indoors. And we do a lot in the area of materials, especially in the area of renewable materials, as I said before, which the topic for today is. The first question, if we come to that realm of renewable materials or materials itself, why do we need new materials? What is the basics, the driver behind that? I would like to show one slide in that direction, which indicates just one of the many reasons we're looking into that area of new materials. And coming from that point where we say in the building sector, what are the challenges? The new materials is basically in a way that we say, okay, we came, and this is indicated in the picture on the right side, we came from buildings which consume a lot of energy during the usage phase, which is the green column you can see here, and just a little bit in the construction and in the production of that building. And at the moment, in Germany, but in a lot of other countries, and I can assume in Brazil also, we are more and more in that area where we say the usage is not anymore that key account to go for new or reduction of energy. It's more the materials. And so we are looking into the materials and see how can we diminish the energy use, the global warming impact, CO2 emissions coming out of the production of that materials. And that is the driving force behind that. And in that area, I have 3 examples which we've done in that area, or which we would like to do also in that area of the new renewable buildings. I have brought one example of a material that we have developed in IBP, which is at the moment at a stage where we can license it, where we can produce it and have to scale it up. One idea about the evaluation of a material which we have looked into in terms of durability, in terms of the possibilities that we can use it in building construction materials. And one example which I see a huge potential in for Brazil, maybe, because looking into a material which is mainly available or a lot available in Brazil, and see how that can be used in as a new material for buildings. Starting with that, the first thing is the development that we have taken for a material which is called tufa or cattail, as you may name it. And we have to look, especially in the realm of the renewable building materials, in different aspects. First of all, it's always the question about the availability, especially in the area to say, okay, we have a competitiveness in terms of food agriculture and agriculture for materials sometimes, but we have to look at that. The second thing is that all the natural-based materials, renewable materials, have normally some issues with the durability. The durability with moisture, the durability with degradation, and so on and so forth, which is our main concern. And then in the end, it's always also the cost. And the cost goes not just about the money, it's the cost in the production, it's the cost in the usage then, and also the cost of the competitiveness. So, which I mean, if we have a standard material, insulation material, and then would like to use another material, a renewable-based material, then we have to go into that and see if it's competitiveness and if it's in the end from the cost side, feasible to use that. And what we have done in that area is to look into that material tufa, and looked into all these aspects. First of all, it was the availability. From a global perspective, there is a lot of potential in it. It's a high agricultural crop, which can be found almost all over the world, in not all climate zones, but in a lot of them. It's a natural monoculture, and it mostly is grown in lowlands, moors, or in areas where no agriculture is at the moment available. So there is no competitive for the food production. It can be harvested, which is also a quite good thing. It can be harvested in winter, which means there's also no production interference with food production, namely. And what we've done then is that we put all the material aspects into place and looked at them and saw that this material is quite good in a lot of terms, because it has a high compressive strength. So we can make plates out of it, which are very strong, but on the other hand, also very good in terms of heat conductivity. They have a good fire protection. As you can see here, it's just an indication, so there's no glowing. and there's also good fire protection in that. It can be worked as wood. It's 100% compostable, and it has easily acceptable in different areas of working there, and that was the basis from the material side to look deeper into it and see if there's a competitiveness in terms of cost, but also in terms of all the other aspects I've named. And we looked into that and saw in comparison to different other materials, aerogel plaster, which is a newer material, mineral wool as insulation material, but also reed boards, which is also another renewable board, and compared that with the brick filled with insulation, so a monostructural in the end. And we then saw that there's a lot of aspects, and I've just named them by preservation, energetic, hydric, operational, economic, which this material is good. So all the green indications are good. And then we have some aspects which they are not so good, which is energetic. So it's not that good in terms of energy saving, but also in terms of the economic aspect. And these two things are then major issues bringing that to the market, but we can solve that. And in the moment, I have to say, it's working out because wood is getting more and more expensive. So this point here is getting more and more into the direction that we can see there's a potential for bringing it into the market and to the market. But the main issue is that the material itself worked, and we could show that this material really works in the building construction and that we can use that there. Just a small example to say what has been made out of it. So you can see here a picture from a building which was built up, or which is actually built up with the tufa board, which with 6 centimeters of the tufa board, and cladded it with clay plaster. And this is the main construction of it. And you can see, okay, there is a good possibility to use that as construction material. There is also wood in that building, but it's mainly out of that tufa board, which is the first example I would have liked to show you. The second thing was that we had to look into new materials and evaluate these materials. This material is widely used. It's bamboo. It's widely used. It also has a good growing rate. There's a vast availability in it. It's excellent in terms of ecological benefits. It grows also in non-cultivated lands, so there's also no hindrance in terms of food competitiveness. And we wanted to know what is happening then with that material, and if we just look at the material, what is happening there and how competitive is it in terms of the durability and also in terms of the other aspects I named. And saying that, the first thing was to look again, and you probably know that there's a lot of areas where bamboo is growing. There are different types of bamboo, and most of them are growing in Asia, but there are also a lot of areas where they grow in America, especially in your area. So main area, Brazil, there's a lot of bamboo bamboo possibilities or growing bamboo there. And the second thing is, with the bamboo, there's a lot of actually available building materials. So the raw material is then worked into different plates of bamboo, flatted bamboo, laminated bamboo, and so on and so forth. So there's a lot of materials which are in place in a lot of building sectors. Also the raw bamboo is worked with, and we had, or in our labs, we looked into that material and saw, okay, and wanted to ask if I hope you can here. I hope that it's going on. Now I'm back in place. So in case you haven't heard me, what we liked to do is that we looked into the material properties of that bamboo, and we like to compare them to wood. And what we found out is that what you can see actually here. So as I said in the beginning, I'm an engineer and I like numbers. So here you are, and have a lot of numbers. We went through all that properties that you can see on the left side: dry bulk density, porosity, equilibrium of moisture and content, which are a lot of measurements taken to see how durable the material is and how comparable it is in terms of its material properties to wood, because wood is a material, a renewable material we knew quite well because we work a lot of that with it and over a lot of years. So if it's quite comparable to wood, then we can see, okay, there's a lot of similarity. And what you can see here is that there's a lot of similarities in there. So from the bulk density, it's closer to hardwood, but it's more wood than softwood, and so on and so forth. Also in terms of the equilibrium of moisture or free water saturation, it's in the area a little bit over it, so it can take more moisture. So that could be a problem in terms of degradation of that material, but we don't know that yet because there's a not too long time that we could look at that. But the thing that we found out is that during our measurements, we saw in the last line the mold grow index, which we indicated. We saw that the mold grow on the material, which was not somehow treated against that mold grow. So there was no covering on it. It was just the material itself. And we saw that there's a very sensitive reaction to that mold growth. So we found out that if we do not treat the bamboo in a good way, then there is a high probability that if we build it into our buildings and see not to it that there's a diminished moisture in that area, that we then have a really sensitive material, which then could be the source of mold growth in our building. So that was the idea of that, to find that out and to see, okay, we have to look into that and see what possibilities are there, or what treatments do we need into that direction if we use that material. And that is the thing for most of that materials that we look into, if they are renewable. You can see that wood is also sensitive to mold grow, but we can manage that because we can treat that with different methods, say to integrate another component, or we put it on a place in a construction where the moisture content is below a certain point in terms of the wood. It's around about 12 to 16%, where we can go into and say, okay, if you stay below that, then all is fine with the wood. And the same issues could go with the bamboo. And stating that, the findings of these investigations are then mostly brought to the building site, and we try to bring them, or we try to see where to implement these materials then in the end. And that was what we've done with bamboo. And the last thing where we see at the moment a quite good potential, and to be honest, I'm not very familiar with the sugar cane or with that potential of that material, but it seems that it's quite similar to a lot of things that we have done. It's maybe a little bit into the direction of bamboo, maybe it's a little bit into the direction of the cattail, of the tufa that I've showed in the beginning. I saw that there is from the the one side, from the availability, a huge potential in that area of the sugarcane, because what I found out during my research, or my small research into that, is that the production per hectare is very high, and also the waste product, the bagasse, or what is left behind then if you use all of it, is a lot of that. It's 35% of that. I also found out that there's an excellent ecological benefit in terms of CO2 absorption, which is a lot higher than we've seen that in bamboo. And I think it could be a possibly very good building material. Also, the availability, and that is especially true for Brazil, because you are the main producers of the sugarcane. Indicated here, it's not just in Brazil, but you are the main of that, followed by India. So there is a huge potential for Brazil itself to look into that. And we also, or I also think that there's a good potential for using that as building material. I know that there's a lot of possibilities, and also has been done, in using the sugarcane or the bagasse as cardboards, papers, food trails, also some kinds of insulation, also some kinds of pipe insulation, and I have also seen boards, but I haven't seen any measurements in that direction, and I haven't seen any possibilities or findings in that direction, of example for the bamboo. We have a lot of ideas in that direction, and we also have a lot of possibilities in evaluating these. And yeah, the questions open, or the questions for the sugarcane, or for that potential to raise, is how does the material in the end really work out? If it's like the pipe insulation, I can assume there is some kind of chemical change in that material. In terms of the plasterboard, I could assume that you just push it together and condense it to a plate, but I don't know the material properties about that and where to use it. In terms of insulation materials and the possibilities there, I think there's a lot of possibilities to produce that, to put it together and have a binder in it, and then make a material out of it. But the questions I have in that is, what kind of material properties do we have? What kind of basic properties, energy uptake in production, and so on. But also the hygrothermic properties, the durability, the water take-up, the mold grow index. I don't know if you have information about that, and I don't know if you are interested in working together in that field. So we see a lot of potential in that. We see possibility in really using that for building, and have a new building material made out of sugarcane. And we can see that there's a lot of similarities from the things that we have to do in order to find out where to use it best and how to use it best. And I would be very interested in seeing your questions or your possibilities in that direction. Stating that, I would like to add one thing short before I come to the end of the presentation. We always think that materials especially should be from the area in which you're working, because we are dealing with worldwide with different climates. We are dealing with different cultures. The acceptability of these materials and the acceptability of the things that we use is always in the middle. So the people are always in the middle. But we have to adapt the climate aspects to that. And in the end, we have to bring up the fitting buildings with the best materials available. I think there's a huge potential in your country for using that sugarcane, but I think there's also a huge potential for using all the other renewable materials in there. But in the end, we have to build the environment, especially for the people, and especially fitted to the cultural and the climatic zones. And with that, I hope you have enjoyed that presentation. I hope you have a lot of questions now open, and please feel free to ask them. I think we have quite time to ask the questions. Otherwise, you can just write me an email or call me or write an email to the email which was indicated in the stream, or connect via LinkedIn. And I'm happy to talk to you and answer your questions. Thank you.
Hello. Thank you, Simon. It was a very interesting presentation. I would see if we have some questions here. If we don't, I do have questions, because these are really, really interesting topics, and that we see in Brazil a huge application. We could apply it everywhere, especially with the amount of sugarcane, for example, that we have, and also maybe bamboo, right? So, I'll put it in Portuguese. Pessoal, se vocês tiverem alguma dúvida, vocês podem colocar aí nos comentários, ou enviar um e-mail para o Simon diretamente, simonschmidt@ibp.fraunhofer.de, ou diretamente para nós, para que nós possamos fazer a ponte, né? info@fraunhofer.org.br. Eu também vou pôr na tela aqui. Mas a ideia é que a gente possa entender, né, se existem interessados no Brasil nesse tema. Eu sei que sim, né? A gente tem uma grande, como o Simon mostrou ali, né? Nós somos os maiores produtores de cana do mundo, de açúcar, né? E conseguimos dessa forma ter a grande quantidade de insumo, obviamente, né? A gente tem já esse insumo sendo utilizado, o bagaço da cana, como gerador de energia, né? E álcool, gerador de energia, né, para realimentar e também cogerar energia para as redes elétricas no Brasil. Mas também a gente tem a oportunidade de criar novos produtos e agregar valor, né, com esse insumo lá no final da cadeia. A gente consegue também agregar outros valores, ter o maior valor agregado para a indústria nacional. Simon, the people are a little bit shy. But I was talking to them the huge opportunity that we have. If they have any questions, they could contact you and us, right? And as they don't have any questions right now, I do have a question. Oops, I think Simon is out. His connection has failed. Então, pessoal, tá esperando aqui a conexão, né? Hoje tá um dia da internet um pouco instável. Então, queria saber se vocês realmente têm alguma dúvida, se vocês querem entrar em contato. Se vocês tiverem, por favor, entrem em contato. Ó, ele tá voltando aqui. Deixa eu ver se... Hi, internet problems, connection problems. You're back.
They're also occur in Germany.
Simon, I do have a question. Actually, there are two questions. The first is, I saw the huge possibilities that we have on applying new materials using the bagasse of the sugarcane after the processing, right? We use in Brazil, especially mostly for co-generating electrical energy and supplying internally and also to sell. But this to sell, that can be selling the energy that could be selling, we could use a small part or a part from the bagasse to use for new applications like you put there. It is, from my point of view, really interesting. What do you do there at IBP that we could also, not only the assessment, but how could you also help the Brazilian industry and also the research and development organizations in Brazil to provide some services and also to support new ideas? What can IBP do that we could also use in Brazil?
Yeah, thank you for that question. I focus today on the material itself and the material properties. What we do is we look from our laboratories a lot into the material properties itself, especially in the durability part of it. But I'm sure that especially in the terms of sugarcane, you are more advanced and do know a lot more in that area than we do. So in that aspect, another point is coming into play, and we use that material then afterwards if we have assessed it in constructions. So different construction types, lightweight construction with different layers, using the insulation on the inside, using it on the outside, see what is best, and also evaluate then in that realm how to best use that material in the end. So the benefit then would be, or what we would bring to the table in that area would be then that we say, you know, the material properties, we have a lot of ideas how to use that, and we can both together evaluate what is the need for the building sector. So do you need more in terms of insulation in most of your climate as it is in our country, and where is then the problem point, so to say? Where is the water coming from? It's the water coming from the inside, which you produce from yourself and going into the material. What is happening then? Have we to protect that material and so on? So seeing into that part, but also in terms of how to cooperate between research and industry. This is our key competence at Fraunhofer itself, and I think this is also a thing which could be applied very good to Brazil in working together with the industry. So both of these aspects, how to use that material in the end, and how to work together would be the point there.
Yeah, that's great. I remember when we first talked that I told you that one of the biggest problems in Brazil is the high incidence of sun, the heat. And how do you think that we could use a lot of these materials for the isolation itself to maintain the temperature, especially where we are during the pandemics? In some buildings, they are forbidden to use the air conditioning system, and then it's some problem that we face. And maybe this kind of isolation, maybe with bagasse and other materials, could be used for our buildings in Brazil. What do you think?
Definitely. So what we see worldwide is that insulation is not just for the cold countries to keep the warm inside. So vice versa. If you think at a fridge, you can see a fridge is also insulated. That's not because you want to have the heat inside, it's because you want to have the heat outside and the cold inside. And the same principle goes with the insulation on the building. So definitely, yes, it can help, and it will help.
Yeah. Okay. So, Simon, I think we don't have any questions anymore. So I would like to thank you very much for your time, for your presentation. And please also feel free to contact us here in Brazil, as I am in Brazil and you are in Germany, because I see a lot of opportunities that could also we could also contact the industry here and could also do something together with the Fraunhofer IBP. Pessoal, muitíssimo obrigado pela presença de vocês. Por favor, fiquem à vontade para entrar em contato tanto conosco aqui da Fraunhofer Liaison Office, quanto o Simon, né, que eu vou deixar mais uma vez aqui o e-mail dele disponível, tá? Essa live vai ficar gravada, então vocês vão ter acesso a ela todos os momentos que vocês quiserem aqui no canal do Fraunhofer Liaison Office. Espero vocês, então, no próximo Fraunhofer Quick Lives e fiquem saudáveis aí, com saúde, até a gente passar principalmente essa fase. Um grande abraço. See you guys. Bye bye. See you next time.
Bye. Thank you for having me.